Welcome back everyone to another video, and in this one I'll be showing off this little project that I did a couple of days ago. It is the part 2 of the VT-100-ish project, which by the way, if you haven't seen, it's basically a DIY laptop. So I'll just go through the external features and then go through inside it. So it has a switch right over here, and you can flip the switch which turns it on, and that powers the onboard monitor, and you have a keyboard. So it's, of course, as you can see, booting up pi 0, and I'll try to put it at an angle that you guys can see and I also can see and work on. But yeah, so it's mostly hacked together with components I had laying around. Again, because of the human malware, you cannot get a lot of stuff these days. So yeah, it boots. There is touch input as well, which I might be able to demonstrate in some way or the other, because the software part is the one thing that's not done yet. So I've made the hardware, I've assembled everything to the point that it works. There's charging, there's you can use it while it charges and all of that good stuff. But yeah, the software part is something that I've been working on and it will be available at some point or the other. So now that's booted on to Raspbian, it will pretty much have a custom Linux OS based on Buildroot or Yocto, as far as I'm concerned. But for now, this I'm just using it for testing. And here I can see you or show you the touchscreen test. So couple of things, and I can run ts test, so that I can just touch and move the cursor around. If it's visible there, maybe now, and I can go into a draw mode, and I can actually draw stuff on the screen. So it's a restive touch, and I'll show how it's all interfaced. So I've not used any of the GPIO pins on the Pi, which is the big thing for me. That means I'm not limiting myself to that Pi 0 I have in there, and I'll talk why I use the Pi 0 and all of that stuff in a second. But first, here's a quick montage on how this all got built. So once that is over, we'll open that up and show you what's inside. So cut to the montage. Alright, welcome back. So let's turn it off and take it apart, and I'll show what all is connected how inside. So again, as I said, this is all recycled parts. The keyboard and this little stand thing came out of a very cheaply available micro USB keyboard and like tablet cover combo, which are like just one hung low stuff I had uh, around, and I was just able to use that directly from there. So not much in terms of cost there. So that was probably the cheapest component next to the Pi Zero itself. And once I open it up, there will be a bit of a mess. And that is what exactly I like about this. It's a very messy project. So there you go. So on this end, on the screen end, and I'll talk about the business end later, but on the screen end we have uh, your LCD driver. This is easily available from AliExpress or somewhere, but because of the human malware situation, you might want to not buy it from there. The LCD itself is has like a restive touch layer on the other end, like just that I just showed. This was a part. This is called the S70, and it is a part that Friendly Arm sold. But Friendly Arm had another daughter board there that made it incompatible with any other controller, basically. So once I earlier didn't realize that they were just using generic LCDs. So I just had this waste lying around because I couldn't use it with any other thing. So but I went once I opened it up, removed that daughter board, figured out that it's the same 50 pin LCD that these driver boards used, plugged it in, it all worked. So that's that. The touch sensor is you using this AR1100 touch to USB mouse device that Adafruit sells. It's a really nice compact unit and takes in the X and Y positive differential pairs from the resistive touch sensor part and converts that into USB, so your device just sees it as USB. And again, no driver needed. That is also driver free. um, on this side, on the business end, what we have is of course the Pi Zero, which we'll talk about in a bit. But here's a 1000 mAh 3.7 volt lipo, which I can change to something else, maybe even a 18650 or stuff like that. But this is compact and good enough for me. The other thing is this charge controller and basically a PMIC, a DIY PMIC module kind of a thing. So this has a bunch of pins that you can use directly or indirectly. So I'm using two of the pins to get the power it would have otherwise gotten from the micro USB as a regular as a micro USB port out the back. Now what that boils down to is I don't have the correct D plus and D minus configuration set up right now to to tell the micro USB port to give enough power to it. But for the time being, I'm seeing anywhere to up to an amp being drawn, which is fine. So maybe if that seems less, I might add a couple of resistors at the D plus and D minus of the micro USB charging port back here, and that would give us much higher current. But for the time being, that's fine. It has an in there 3 pins, basically VS, ground, and enable. So if you again short the enable pin to the VS pin, it turns it on, short it to the ground, it turns it off, and that is what we are using to power the whole system. Now I can have it plugged in and it can be charging while it's turned off, or I can have it powered on and it still will be charging while it's plugged off, and there are charge indication LEDs. Just to maybe demonstrate that quickly, so I plug this in and it starts charging, and I can power it on while it's charging and it will power on. So that's that. Moving on to this little thing here, which is a 7-port USB hub. Now in most USB hubs are 4 port. That's sort of the max USB 2 hub capacity. I think it's the same for USB 3 as well. You can only have 4 hubs from a single port. So this does basically daisy chains two hubs together and then makes it a 7 port hub. Now the reason I didn't take it out of the PCB is just for sturdiness. Yeah, I'll be plugging things in and out. Again, this is primary as a replacement for an old school VT terminal, so I'll be mostly plugging in USB to UART connectors, or other USB to onboard UART stuff, or even serial port and weird stuff like that. So that's what's the use case of this thing. Plus it connects the USB keyboard as well as the touch sensor here to the Raspberry Pi Zero, which is connected again using the pins beneath the micro USB port. Connects that to the micro B port, the mini B port here. And this is the main power. This also distributes power to the Pi itself, because this is a powered USB hub, so it can take power directly from the PMI, the DIY PMIC. The Power Boost 1000C is the name of this module. So it takes power from the Power Boost 1000 and then distributes it to the Pi Zero, the keyboard, the touch sensor, and I've just run another cable straight to the module here, because that was just the LCD driver, because that was just easy. So that's how that's handled. The Pi Zero, I've used it because not really many Linux SBCs of this size has an HDMI port, runs off of 5 volt and just sips power. So I have a lot of SBCs that sip power, that are this small, but don't have HDMI ports. I have a lot of SBCs that don't sip power, are this size and have an HDMI port. I just have a lot of SBCs that sip power, have an HDMI port, but aren't this small. So this was just sort of that perfect combination at this point. Price wasn't much of an issue, but if I come across another SBC that maybe has a couple more cores, higher clock, more RAM, but fits the form factor and has an HDMI port, I will be willing to use that. But for the time being, this is the only thing in my compartment or in my inventory that does this. And again, this is all from the stuff I have laying around. The human malware times, you can't really go out buy stuff. I can't even order stuff, like all the shipping is stopped. So this is what I had lying around. And this is how it works together. Now what I really like in this project is this ribbon HDMI cable. This is now, I'm not sure, I think Adafruit sells these as well, so I'll leave like a hardware list in the description if you want to buy everything. Again, Adafruit is not sponsoring any of this stuff, but I just happen to have 3 of their products lying around. So these are like DIY HDMI cables, so you can buy the endpoints separately. You can buy a mini A, mini B, and you can make weird combinations. So you can go from micro HDMI to mini HDMI, have different like angles to them, and do weird stuff. And then you can buy these cables separately. These are ribbon cables that have like a cloth backing to it, so it just adds a bit more strength, and you know, the signal integrity is is actually pretty good. So that works out as well. Apart from that, nothing much. It just is basically desktop setup into a thick compartment, and that is how it operates. Again, the idea was basically to have this laying next to my desk, and my workbench, not my workstation desk, which is where the system is, but my workbench, and just have a easier and smaller UART terminal that I can just plug boards into and test while I'm doing stuff with them. at times I don't have space on my main desktop workbench or stuff like that to have the board there, have the power supply there, and power everything. So this was the intention, to move all of that away from my main computer workstation so that I can remotely do all of that stuff. This also enables me to maybe SSH into those boards over UART. um, I mean SSH into this and then connect over UART. So sort of work in progress labish sort of thing. I have a lab that also has another device that connects UART to a bunch of things, but that's just like the devices are there, and I also don't have to interact with them. This is where I have to interact with the device, like I'm adding a sensor, they're removing a sensor, and I just want to quickly test if that connection works and stuff like that. So again, niche use cases, but here we are. So this is about it for this video. The next video will be on the software bits, which sadly have to be custom. Just trying to find something that works for me, but I'm not. So a custom software stack, probably super lightweight, again based on Linux for the most part. But yeah, let's put it back, and thank you everyone for watching, and hopefully please do leave any comments you have in the comment section down below. Let me know if any improvements or changes you need to see. um yeah, I guess that is what I have at the moment. Thank you so much for watching, and I will see you all in the next one. Bye.